Hey everybody, welcome to Algo Expert. In this video, we're going to be covering the question of calendar matching. I really like this question for two reasons. Number one, it's got a very legitimate real-world application, as you'll soon see. And number two, unlike a lot of other coding interview questions, I think that the coding part of this question is quite a bit more difficult than the algorithm part of this question. As you'll soon see, while the algorithm part is definitely not trivial, it is pretty logical. It's probably the way that you would solve this problem if you were given this problem in the real world, in a real world setting. The coding part, however, is pretty tricky. Without further ado, though, let's jump into the question. In this question, you're given the following scenario. You are working at a company and you want to schedule a meeting with one of your coworkers. Now, as you can imagine, that meeting that you want to schedule is going to have a duration. Maybe it's going to be a 30-minute meeting. Maybe it's going to be a 1-hour-long meeting. And you're given that duration here. On top of that, as you can imagine, both you and your coworker are busy. You've got stuff to do during the day. And typically, when you're working at a company, what you have is a calendar that tells you what times of the day you're busy and what times you're not busy. So here, you want to find when you could schedule this meeting with your coworker, given the duration of the meeting and given your two calendars that tell you when you're sort of busy, when you have other meetings already scheduled. On top of that, you're given two other inputs, which are sort of the daily bounds that you and your coworker have. As you can imagine, you probably only get into the office at, let's say, 10 a.m. And you get out of the office, you leave the office at, say, 7 p.m. So you would never want to schedule a meeting before 10 a.m., and you would never want to schedule a meeting after 7 p.m. And so you have these sort of daily bounds for both yourself and your coworker. Now, given all of these inputs, you want to find the ranges of time in the day when you could schedule a meeting of the duration that you want with your coworker. So in the example in front of me, as you can see, we've got one calendar here that's got a few meetings, right? One meeting from 9 a.m. to 10:30 a.m., one meeting from 12 p.m. to 13 p.m., which is 1 p.m., and another meeting from 16 to 18. We're using sort of a military time here. Then you've got your daily bounds. At 9 a.m., you get into the office and you leave at 20, which is 8 p.m., I guess. And then you've got a second calendar, a third calendar, and I forgot to write the duration here, which would be, I believe, 30. And the answer here is going to be these three ranges of time that I've written in purple at the top, from 11:30 a.m. to 12 p.m., from 15 to 16, and 18 to 18:30. These are the three ranges in the day, given the inputs, where you and your coworker could have a 30-minute meeting. So how do we solve this problem? The first thing to ask ourselves is, what does it mean for a range to be valid for both of you to have a meeting? Well, it means that you would both have to be not busy, meaning both of you would have to not have a meeting in your calendars during that range, and that range would have to be equal to or greater in terms of time to the meeting duration that we're given in the function. So basically, if we had a calendar that gave us all of the meetings during the day of both you and your coworker, in other words, all of the blocks of time where both you and your coworker, or at least one of you, is unavailable, then we would be able to solve this question pretty easily, right? If we were told, oh, between this time and that time, at least one of the two coworkers is unavailable. Between this time, this other time, and that other time, at least one of the two coworkers is unavailable. If we were given that, then we would be able to easily find all of these sort of availabilities in between these blocks of time. We would make sure that these availabilities are at least 30 minutes long, or however minutes long we need, and then we would find the answer like that. So, how do we convert these four inputs, right, these two calendars and the two daily bounds, into sort of one calendar of all of the unavailabilities where at least one of the two coworkers is unavailable? Well, it's pretty simple. The first thing that we need to do is we should update both calendars to take into account the daily bounds. So here I'm going to start moving stuff around a little bit. But if we take the first daily bounds of 9 a.m. to 20 p.m., or whatever that is, 20, then we can create sort of two additional meetings that would look something like this. We would have one meeting from 00 to 9:00, and that meeting would go up here to the left. It would be sort of the first meeting in the day for the first person. And then we would have another meeting from 20:00 all the way to 23:59, which is sort of the last minute of the day. And that would go up here in the, let me undo that, up here in the sort of upper right corner of the first calendar, or sorry, to the far right of the first calendar. Similarly, for the second calendar, we would create two additional meetings from the two bounds. So if we grab, let me grab these bounds and move them. And move them down here. We would have two additional meetings, one from 00 all the way to 10 a.m. That would go to the left at the very beginning of our calendar. And one from 18:30 to 23:59. And that would go to the far right of the calendar. So now we've got two sort of updated calendars that really tell us, for both individuals, when they are busy. So I'm going to erase now the daily bounds. We don't really need them anymore. We have them captured in our new updated calendars. And now what we need to do is we want to say, let's merge these calendars. We no longer want to deal with two separate calendars. Let's just deal with one merged calendar that basically tells us what the unavailabilities of these two individuals are. Because remember, if we're trying to find a meeting that matches for both individuals, then we need the availabilities or the blocks of time where not just one, but both individuals are available. And so the sort of opposite of that is a calendar of all of the unavailabilities where at least one person is unavailable. And what is that? It's basically just merging the two calendars. And the way that we're going to merge these two calendars is we're going to merge them in a sort of merge sort fashion, if you're familiar with the merge sort algorithm, which we have here on the platform, where we want the calendars to be sort of ordered from beginning of the day all the way to the end of the day, because that's going to make things a lot easier for us when we finally have to find the availabilities. So since our calendars are already ordered right now from the beginning of the day to the end of the day, that's how the question gives us the calendars. If we want to merge both of them in a sorted order, then we can do so in a merge sort fashion where we iterate through both calendars, looking at the first value in the calendar at any given time and seeing which one is smaller than the other. And here specifically what we're going to do is we're going to compare the starting time of a given meeting. Okay, so in this example, let me move the duration of 30. We'll move it to the top right now. And hopefully we'll have enough room here at the bottom to write our sort of merged calendar. But basically, we would put pointers at the beginning of both calendars. So we would have, one pointer, I'll put them maybe in purple. We would have one pointer right here under the first meeting, which was created based off of our daily bound. And we would have another pointer, we'll put this one in orange under here, under our other first meeting. And we would say, okay, which one has a starting time that's smaller than the other? So here they're both equal. They both have the same starting time. So we'll have to figure out in our code if we do, lesser than or equal to. It doesn't really matter. But so since they both start at the same time, we can pick either or. Okay, we'll pick maybe the second one. So in our new sort of merged calendar of the unavailabilities of both coworkers, we'll start by putting 0:00 to 10 a.m. Okay, that's our first meeting. And now we will erase our pointer, our orange pointer here, and we'll move it to our second meeting. So here, instead of putting a line, because that'll be tricky to erase, I'll just put an X. So now we are under this meeting here. And so now we compare again the start times. Is this meeting 0 to 9 a.m.? The start time 0 smaller than 10 a.m. Yes, it is. So we're gonna add our second meeting here, which is gonna be 0 to 9 a.m. Right? And we're gonna move this line. I'll erase it. Let me try to be careful when I erase it. Whoops. And we will put our next pointer under here, under 9 a.m. to 10:30. Now we compare, is 9 a.m., this start time, smaller than 10 a.m.? Yes, it is. So we're going to move this meeting, which is going to be 9 to 10:30 here. And we're going to move our pointer to here, to 12 to 13. Now we compare again, the start time of 12 to 13 compared to the start time of 10 to 11:30. 10 is smaller, so we grab this meeting. And that's going to be, let me try to be straighter here, 10 to 11:30. Move the pointer. So as you can see, again, if you've done the merge sort question on AlgoExpert, this is exactly like we sort two subarrays in merge sort. You have two pointers and you compare the smaller one that you add to your new array, and then you sort of increment the pointers. So now I guess I'll go a little bit faster. I'm no longer going to look at the pointers. I'll just do it very quickly at a glance, since I think it's pretty clear the sort of technique that we're using here. But the next meeting is going to be 12 to 13. The meeting after that is going to be 12:30 to 14:30. The meeting after that is going to be, 14:30. The meeting after that is going to be 14:30 to 15. The meeting after that is going to be 16 to 17. The meeting after that is going to be 16 to 18. The meeting after that is going to be 18:30 to 23:59. And the final meeting is going to be 20:20 to 23:59. So as you can see, let me erase the 2 pointers. We've basically merged both of our calendars, right? Both of our calendars that have the sort of updated bound meetings that we did at the beginning, right? And we've merged them in ascending order based on the start time of every meeting. So we know that if we go from left to right here, we have meetings that are sorted from start time that represent all of the times where at least one of the 2 coworkers is unavailable. Now, what do we do from here? How is this useful? Well, remember, we said if we have all of those blocks of time, then we can just look at the blocks of time sort of in between these blocks of time. And those blocks in between would be the times where both coworkers are available. And if one block of time there is bigger or at least equal to our meeting duration, then it would be one of the valid blocks of time that we want to return. The problem here is that our merged array, or our merged calendar, is kind of all over the place right now, because it is sorted based on start time, but it's kind of crazy looking in terms of end time. Like, for instance, here we've got 3 meetings, we've got 4 meetings, the first 4 meetings that could actually be merged into one. Like, this first one says, okay, we're unavailable from 0 to 10 a.m. The second one says we're unavailable from 0 to 9 a.m. Well, okay, this entire meeting here is sort of captured in that first one, right? 0 to 9 a.m. is captured in 0 to 10 a.m. So we could sort of merge those 2. Then we've got this one, 9 a.m. to 10:30 a.m. Well, okay, that means that we could probably merge these first 3 meetings into 9 a.m. to 10:30 a.m., right? And then, I guess, let me undo all of this that I just wrote. And then we've got that fourth meeting, 10 a.m. to 11:30, that could also be merged into those. So basically these first 4 meetings could be merged, or here I'm actually going to use the term flattened, because flattening is a sort of common technique in coding or in algorithms, and here this is exactly what we're doing. We're sort of flattening this array, or these ranges, into fewer ranges that can capture multiple ranges at once, right? So here again, what we're doing is we're saying, okay, we've got this calendar of all of the unavailabilities of at least one of the 2 coworkers, but some of them overlap, so we're going to flatten them such that they no longer overlap, and then we'll have something much more valuable. So let's see if we can flatten them. The first flattening is exactly what I just said. Let me redo this. It's exactly what I just said. These first 4 that are going to be, maybe I'll write them in orange, 0, 0, all the way to 11:30. Now we'll see in the code how we actually do this flattening, because that's where it's sort of non-trivial. But here, as far as, conceptually this goes, it's pretty obvious that these 4 meetings can be merged into one meeting. You can kind of see that, okay, we've got 4 meetings, and if you merge them or flatten them, then we've got one block of unavailability from 0 all the way to 11:30. Then we can look at the second, or the following meetings. We've got one from 12 to 13, but the next one starts at 12:30, which is sort of in the middle of 12 to 13, and it goes all the way to 14:30. The one after that starts at 14:30, which is directly connected to the previous one that ends at 14:30, and it ends at 15. And then we've got 16. So 16, there's definitely a gap between 15 and 16 here, but these 3 other ones can be captured. So we'll say, let's see, how do I do this? We'll say these 3 ones here, right? Maybe I'll circle all of them. The first ones are circled like this. These 3 ones here can be captured in 12 all the way to 15, right? And then we've got 16 to 17, 16 to 18, so these can obviously be merged. Basically, the 16 to 17 one is directly captured inside this one. Then 1830 to 2359, so 1830, there's a gap between 18 and 1830. So basically, these 2 can be captured here, and that's just going to be 16, 18. And then finally, these 2, 1830 to 2359 and 20 to 2359, can be captured into 1830 to 2359. In other words, the second one here, the last meeting of the day, is captured into this one. In other words, between 1830 and 2359, there's always at least 1, but sometimes even 2 people who are unavailable. So we're going to circle that, and we're going to say that is going to be 1830 to 2359. So now we've got a final sort of flattened calendar of unavailabilities, where the blocks of time represent a block of time where at least one of the 2 coworkers is unavailable. So between 0 and 11:30 a.m., at least one of the 2 coworkers is unavailable. So there's no point in putting a meeting there. Between 12 and 15 p.m., at least one of the 2 coworkers is unavailable. You can't put a meeting there. Between 16 and 18, at least one is unavailable. And between 1830 and 2359, at least one is unavailable. And so now, how do we find the availabilities where we could fit a meeting of 30 minutes? Well, we check all of the gaps in between these meetings. So the gap right here, right, this circle in between 11:30 and 12, can we fit a meeting of 30 minutes in here? Yes, we can. So we create a range, which I guess I'll circle in orange up here, 11:30 to 12 p.m., right? We take the ending time of the previous meeting, or the previous unavailability. We take the starting time of the next meeting, or unavailability, and we create a range. Here, we've got 30 minutes at least where we can fit a meeting. Then we take the next range, or the next in-between range. Now here, because of the way I've ordered my things, I can't really put that purple circle. But basically, between the next unavailability of 12 to 15 and the one after, 16 to 18, you can see there's 1 hour between 15 and 16. So we can make a range, 15 to 16, where we could fit a 30-minute meeting. And then finally, between 18 and 18:30, there's also a range, which is why we have 18 to 18:30 right here. Now, it's important to note that here, let's say that this last range, instead of having been 18:30 to 23:59, let's assume that it had been 17:30 to, or wait, not 17:30, but let's assume that it had been 18:15, right? If it had been 18:15, then between 18 and 18:15, there would not be enough to fit a 30-minute long meeting, so we would not have put that final range here. But here we did have enough, so we could put it here. I'm going to undo this. Now, let's look at the time and space complexity. Let's see if I can give myself a little bit of room right here in the middle to right here where I'm pointing to put the time and space complexity. These are actually going to be pretty simple. The time complexity is going to be equal to O of C1 plus C2, where C1 is the length of our first calendar, and C2 is the length of our second calendar. Because as you can imagine, when we update the calendars, we sort of just add, 2 extra meetings at the beginning and at the end. When we merge the calendars, we have to iterate once through both calendars. And then when we flatten the calendars, it's sort of the same thing, right? We're iterating through that main merged calendar, which might be at most length C1 plus C2. So we would have O of C1 plus C2. And finally, at the very end, again, when we find the availabilities in between, same thing. At most here, if all of the meetings never overlapped and our merged calendar was just basically a combination of C1 and C2 where none of the meetings overlapped, then we would iterate through C1 plus C2 ranges, right? So the time complexity is going to be O of C1 plus C2, and by the same logic that I just gave, the space complexity is going to be O of C1 plus C2, because we're probably going to be creating new versions of these calendars, certainly for the merged calendar and the flattened calendar, but even the updated calendars. And also here, there's something that I didn't mention, which we'll see clearly in the code, but we're probably going to be creating new versions of these calendars where we transform the ranges of time to something more usable for mathematical comparisons. Like when we're, for instance, comparing, is 9 a.m. smaller than 10 a.m.? Here, for us, it's very easy as human beings to say, oh yeah, of course 9 a.m. is smaller than 10 a.m. But when we're going to be dealing with strings in our code, we're going to want to convert these times to numeric values. We'll probably convert them to just a numeric value that represents the number of minutes in the time. And as you can imagine, we're probably going to have brand new arrays holding these sort of formatted values. But again, we're never going to exceed O of C1 plus C2 space. And perhaps this will be a lot clearer in the code. So with that, let's jump into that code. All right, so we've got our calendar matching function defined. It takes in 2 calendars, it takes in 2 daily bounds, and 1 meeting duration. And the first thing that we're going to want to do is to update our calendars to account for the sort of artificial meetings that we're going to add at the beginning and at the end of both calendars because of the daily bounds. We're also going to update these calendars to make them more easily manipulatable when we have to compare times to each other. So we're going to do this with a helper method. We'll say updated calendar 1, right? We're going to create a new variable, updated calendar 1 equals update calendar. This will be our helper method. And this is going to take our calendar 1 as well as our daily bounds 1. And we'll call this a second time, except here we'll pass in calendar 2 and daily bounds 2, and this will be updated calendar 2. Now, before we move forward, let's actually define this update calendar method. It's going to take a calendar and daily bounds, as we just said, And the first thing that we want to do is create a copy of this calendar. We won't necessarily need to make a copy, but it's typically preferred to make a copy of something that's immutable so that you never sort of mess with the original parameters. This is something that you would probably want to tell your interviewer. Generally speaking, I advise making copies of inputs so as to not mutate them. So here we'll say updated calendar, calendar is going to be equal to a copy of our calendar. And then we're just literally copying that calendar, right? We could use a for loop or whatever. In Python, we can just very cleanly slice the calendar using this syntax. And then we're going to insert at the beginning of the calendar, so updated calendar dot insert at index 0, a new meeting, a sort of artificial meeting that starts at time 000 and ends at daily bounds at index 0, which is the sort of starting time of the first coworker's day. And then we're going to do the same thing, except we're going to append at the end of the array, right? Or at the end of the new updated calendar. I should add a D here, updated calendar. And here we're going to add a meeting that starts at the second daily bound at index 1, and that ends at the final time of the day, which is going to be 23:59. Because the day ends at 23:59. Now here we could definitely return the updated calendar, but we're not going to do that. We're actually going to try to transform, as I mentioned before, this updated calendar into something that's more easily manipulatable. So more specifically, when we're going to be comparing times, like for instance 000 to, for instance, maybe 23:59, it's going to be pretty complex, if not impossible, to compare string values. So what we're going to do is we're going to transform all of these string values to numeric values, and we're going to make them numeric values representing the minutes that these values hold. So for instance, if we have the time, I don't know, let's say we have the time 1 a.m. That would be 60 minutes. So we would turn that into 60. If we had the time, I don't know, 2:30, that would be 150 minutes, right? 2 times 60 plus 30. So we're going to make a helper method to transform times into minutes, and we're going to transform this entire updated calendar into minutes rather than these sort of string representations of times. So we'll say return a list of a map where we map the updated calendar. Keep putting update calendar, where we map the updated calendar. And for every updated calendar, we call a lambda function, lambda m. M is going to be for meetings. And we return, and here we're going to call our helper method, time to minutes, passing in m at index 0, right? And time to minutes, passing in m at index 1. Okay, so all we're saying here is we're returning a version of the updated calendar where we've mapped every meeting m to this array, which basically converts the first value, the start of the meeting, and the second value, the end of the meeting, to minutes. So now we can declare this time to minutes function. This is going to be a function that takes in a time, right? And the first thing that we want to do here is we want to split the time into the hours and the minutes, because the first value in the time, like the time is in the form of, 4:00, for instance. So we're going to split the time, right? Time dot split at the colon. Then we're going to map the two values that we've just split into integers. So we'll create a list out of the map, right? That takes in time dot split. Let's see if I've got the correct parentheses. Yes. And here we're going to do a lambda function. I guess we can just use the integer function in Python, right? The integer function where you do int, let's say a string of 4, this is going to convert this to an integer 4. So here we can do, we've created a list of the hours and the minutes in our time, and we can say hours comma minutes equals this, right? So again, here if we had the time, let's say 4:30, then here we would have hours minutes equals 4:30. This is what we would have from this that we've written right here. So now that we've got this, we can say just return. We want to convert this all into minutes. Return hours multiplied by 60, because there's 60 minutes in 1 hour, plus minutes. And now we've converted our time into minutes. And so now our two updated calendars are in the form of something like, 0 to 150. Sorry, 0 to 150, that would be one value. Then maybe, 280 to 940. I'm just giving examples, but that's sort of what the two updated calendars look like right now. Now, the next step that we want to do is we want to actually merge these calendars. And we said that we're going to do so in a sort of merge sort fashion. So merged calendar equals merge calendar, merge calendars. And here we're going to pass in two calendars, updated calendar 1 and updated calendar 2. And so the merge calendars method, we'll put it down here. It's going to take in two calendars, calendar 1, calendar 2. And I guess we'll declare our merged calendar here. Merged, it's going to be an empty array. And we're going to have two pointers iterating through both calendars, just like we do in merge sort. So we're going to have ij equals 0, 0. And so long as I is less than the length of calendar 1, and so long as j is less than the length of calendar 2, we're going to keep iterating through the calendars. We can declare two variables just to make this easier to parse. Meeting 1, meeting 2 are going to be equal to calendar 1 at index I. Whoops, what am I doing? Calendar 1 at index I, calendar 2 at index j. And if the starting value, because we're sorting or we're merging both of these calendars to have them in sorted order based on the starting value, right? So if the starting value of meeting 1 is smaller than the starting value of meeting 2, so index 0, then we append to the merged calendar, which we've called merged, we append meeting, append, not app, append meeting 1, and of course we increment the I index. Otherwise, we append meeting 2, and we increment the j index. Now here, it's important to note that you could put meeting 1 at index 0 less than or equal to meeting 2 at index 0. It doesn't really matter. I'm just going to go with less than. And the less than or equal to, the case where they're both equal, we're just going to go into the else statement. It doesn't really matter how we handle that. Now, it's important once we've finished iterating through this while loop to realize that, hey, when we're done iterating through this while loop, we're likely only going to have been done adding all of the values of one calendar, not both, right? Because this while loop continues to run so long as our I and our j indices are in bounds, but it's going to break once one of them goes out of bounds, but the other might still be in bounds. So here we have to go through this sort of tedious double while loop where we have to say, so long as I is less than length of calendar 1, then merged dot append meeting 1 and I plus or equal to 1. And you can imagine here, let me give myself a bit more space. You can imagine here that if this condition in the while loop had broken, then here this code just sort of gets skipped, right? But if it hasn't broken, if we broke it with this condition, meaning we've added all of the values in calendar 2, but not all of the values in calendar 1, then this code is very important. And then we can do the same thing. So we duplicate this code while j is less than length of calendar 2, merge.append meeting 2, and j plus equal to 1. And then finally, we return the merged calendar. So now we have merged our calendars such that they are in sort of ascending order based on the starting value of each meeting, but they might be overlapping a lot. And so that's why we're going to want to flatten them right after this. One other thing to note is that these comparisons of the values in the meetings are done so easily because we've mapped all the values all of the times to minutes, right? And we can just do very simple arithmetic comparisons or numeric comparisons. Okay, so the last part of the before last part, I think, of this algorithm is going to be to flatten this merged calendar. So the flattened calendar is going to be equal to flatten calendar. And this is going to be a helper method that takes in our merged calendar. This is probably going to be the toughest method, I think, to write here. Maybe the merged calendars was sort of difficult as well, though I think the flattened calendar is definitely a little trickier. Because the flattened calendar, basically, we have to find all of the values in the calendar that sort of overlap, right? And they might overlap because they're going to be one meeting is going to end right when the next meeting starts. Or maybe one meeting is going to be contained in another meeting. Or maybe one meeting is going to start before another meeting ends, but is going to extend the duration of that meeting. So there are like a lot of cases. We can actually handle all of them pretty elegantly with this method. So we declare a flattened array, which is going to start by having the very first meeting of our calendar. So calendar at index 0. And here I'm going to go ahead and make a copy of that. Like here we're dealing with, maybe, 00 to 9 a.m., right? And this would be actually minute values. So 0 to, let's say, I don't know what 9. We'll do 2. Imagine it's 120 minutes, right? We're going to go ahead and make a copy of that because we're actually going to be overwriting maybe certain values in here. And let's just be safe, make a copy. That way we're never mutating all of these previous parameters. Like I said, I think that in general, it's always good to err on the side of caution and make copies of mutable objects rather than mutate them directly, because you never know where these objects might be used elsewhere in your code, especially when you're working in a more, large-scale production code base, maybe outside of the scope of a coding interview, but it's always good to sort of point this out to your interviewer. We're going to copy this out of precaution. So, okay, this is our flattened array. And now we're going to say, okay, let's iterate for I in range starting at 1, because we've already put the first meeting in the calendar, starting at 1 all the way to the length of the calendar. So we're going at the end of the calendar. And here, important to note that we are dealing with the merged calendar, right? This is the one single merged calendar. And so we're gonna, as we iterate through the calendar, we're gonna declare a few variables to make this more easy to read or more easy to parse. So current meeting, the current meeting that we're at, is gonna be calendar at index I. The second meeting, the previous meeting, is going to be calendar at index, or actually this here, what we're going to be dealing with is not the previous meeting in the calendar. What we're saying here is, as we iterate through this calendar and we append meetings to our flattened array, at any point in time, we want to see if the last meeting that we've appended in our flattened array can actually be updated. So the previous meeting, or extended rather, so the previous meeting is not going to be calendar at index I-1. It's going to be the last meeting that we have in the flattened array. And that's sort of why we initialize the flattened array to hold the first value in calendar. And this is sort of the tricky part of this flatten function. So we're going to say previous meeting equals flattened at the last index. So in Python, we have the luxury of doing -1, but probably in your language, you might have to do flattened at index flatten.length -1. So we take the last value in our flattened array, and then we are going to say, okay, what is the current start time and the current end time of our meeting? So current start, current end, equals current meeting. And similarly, previous start, previous end equals previous meeting. So we declare these 4 values so that we can easily compare them and we know what we're talking about. And here, if the previous end, right, if the ending time of the last meeting that we've appended to our flattened array is greater than or equal to our current start time, then we know that our meetings overlap. Our meetings overlap, and so we're going to create a new meeting, our new previous meeting, and this new previous meeting is going to overwrite the previous meeting. We're basically going to say, hey, the last value that we've appended and flattened overlaps in some way with our current meeting, so we're going to create a new previous meeting, which is going to overwrite that. And basically here, I'll give you a spoiler alert. We're going to do something like flattened at index -1 is equal to new previous meeting. But how do we populate this new previous meeting? Well, we know that the arrays or the meetings were sorted in ascending order based on their start time. So we know that the previous start is definitely smaller than our current start. So that's going to go there, especially if the previous end is greater than or equal to current start. But the ending time is no longer the previous end. It might be previous end if previous end is also bigger than current end, meaning that current meeting is entirely captured into previous meeting. But we have to make this check. So we're going to say maximum, the ending time is the maximum value between previous end and current end. So here, this is really the tricky part of the algorithm. So I want to make sure that this really clicks. If the previous end is greater than the current end, and obviously it was greater than or equal to the current start, then that means that the current meeting was entirely captured in our previous meeting, and our new previous meeting is basically just going to look like something like previous start, previous end, which is sort of a duplicate of previous meeting. If our current end is greater than our previous end, then this is now going to look like previous start, current end. And that means that the current meeting overlapped in some way with the previous meeting. Very important. Okay, so now we can delete this. And then if we don't hit this if statement here, where the previous end is greater than or equal to the current start, that means that we've got sort of 2 detached meetings, and there's some block of time in between them that might be like an availability for us. And we're just going to say flattened dot append. Dot append current meeting, and we are going to make a copy of that again, just out of precaution. Right? Make a copy of the current meeting out of precaution and append it to the flattened. And that's it. This is our flattened function. Okay, so we iterate through all of the calendar, and at every point in time, we sort of compare the current start time of our current meeting to the end time of the meeting that we previously appended to the flattened array. And depending on that, we might have to sort of extend the previous array or the previous meeting that we appended to the flattened array, or we'll just append the current meeting, more specifically a copy of that current meeting. So now we've got our flattened array or our flattened calendar, and we are going to do one last thing, which is to get the matching availabilities for our meeting. Because remember, like, all of this is to find a meeting or a block of time or multiple blocks of times where we could have our meeting. And so we're just going to return a call to another helper method, get matching availabilities. Get matching availabilities. This is a tough word to spell. And we're going to take in our flattened calendar as well as our meeting duration. And now we're done with the main method. And this method is going to be a little bit, this is actually going to be a pretty simple method. It's going to just sort of try to find the blocks of time in between all of the other blocks of time. Right? So it takes in a calendar and it takes in a meeting duration. And it says, okay, we've got matching availabilities, which is an empty array. And we're going to iterate through the range of meetings in our calendar. We'll probably start at the second meeting again, because we're going to be comparing. We're going to be trying to get ranges in between meetings. And there is no meeting before the meeting number 1. And we know that meeting number 1 always starts at 0, 0, right? It'll never start past 0, 0. So we're going to say for I in range 1 len of calendar. The start time that we're looking for is calendar at index I minus 1 at index 1. So the start time is the end time of the previous meeting. The end time is calendar at index I at index 0, the start time of our current meeting. I suppose that here we could also create two variables, current meeting and previous meeting, if we wanted to. And the duration of this availability duration, is going to be end minus start. This is how long we have in this block of time where we are both available, both coworkers are available. And if the availability duration is greater than or equal to the meeting duration, then as you might have guessed, we've found a matching availability. So we can say matching availabilities dot append, and we are going to put start to end. And finally here, we're going to obviously do this for all of the, while iterating through the entire calendar. And finally, we're going to return the matching availabilities. Now, if you've been following carefully, you might have realized that the matching availabilities here are going to be a bunch of ranges where the values are numeric values of minutes. So we need to reconvert that back to our sort of stringified times. So we are going to do the exact same thing as time to minutes, except in the opposite direction. So here I'm probably going to say we're going to return the same sort of list and map like this. Whoops, let me just grab this entire thing here. And we're going to copy paste it here. Except we are going to take matching availabilities instead of updated calendar. And instead of time to minutes, here we're going to do minutes to time. And now we're going to define another function that's going to be minutes to time. It's going to take in minutes. And so here we're going to say, okay, the hours are equal to our minutes divided by 60. And in Python, when you do 2 slashes, you are flooring that value. You are rounding it down. Depending on your language, you might have to do, math.floor or just simply floor here. This tells us how many hours we have in these minutes, rounded down. Then our mins, of course, we can't do another minutes, but our mins, well, we could do another minutes, but I don't want to override that value here because we might need it later. Our mins are going to be minutes modulo 60. Right? We use the modulo operator here to find the number of minutes. Our hours string is going to be equal to, we're just going to convert our hours to a string, right? And then our minutes string is going to be equal to, I guess we have to add here a 0 if there is, if we have fewer than 10 minutes, we have to add a 0. So 0 plus string of mins if mins less than 10, else string of mins. And then we have to do return hours string plus colon plus minutes string. I guess here, this really depends. Like here we're saying, if we have fewer than 10 minutes, make sure to add a 0 before the string of minutes. Otherwise, just return the string of minutes. I guess we would maybe have to do the same thing for hours, because here we did, here we just did 0. We didn't do 0, 0. Yeah, so we're just going to go with this. Here, if you were talking to your interviewer, you would want to ask them, do we want to have always 2 digits for minutes and only 1 digit sometimes for hours? Have them sort of like tell you what they want. This is sort of how it's typically done in the US, where if you have 1 hour, you only put 1 digit, but even if you only have, or if you have 1 digit of hours, you only put 1 digit, but if you have 1 digit of minutes, you put 2. Okay, you get what I mean. But so that's it. This is our minutes to time function. And I guess I'll remove all this extra space that I had down here. And that's our algorithm. And so as far as time and space complexity, you can see updating the calendar, we're making a copy of calendar. So we're, O of C time here. Then we're adding a couple things. These are pretty simple. Then we do a mapping, which is going to be O of C time. For every element, we know there's at most 2 elements that we're calling time to minutes on. Time to minutes here, this is a constant time operation because it's only 2 elements. Then we do that twice. So O of C1 plus O of C2, and we're creating, extra space. So O of C1 plus O of C2 space. Then we merge the calendars. So this is going to be at most O of C1 plus O of C2. This is going to be always O of C1 and O of C2 because we are always iterating through both calendars. And then flattening the calendar is going to be at most O of C1 plus O of C2 because it is possible that all of the meetings or none of the meetings would overlap, in which case our merged calendar would, this will also always be O of C1 plus O of C2 because our merged calendar will always be of length C1 plus C2. However, our flattened calendar, the final version of our flattened calendar, might be smaller. In fact, it'll most likely be smaller unless none of the meetings overlap. And then finally, for get matching availabilities. And as far as space, this will never be more than O of C1 plus O of C2. And merged will be O of C1 plus O of C2 space. And then get matching availabilities, sort of the same logic applies here. You're iterating through a calendar that is smaller, or at most O of C1 plus O of C2 length, and you are doing sort of O of 1 operations. And then finally, when you do this mapping here, sort of the same thing. And minutes to time is, again, an O of 1 operation. So with that said, this is going to be O of C1 plus C2 time and O of C1 plus C2 space, where C1 is the length of the first calendar and C2 is the length of the second calendar. And we can disregard daily bounds and daily bounds 1 and daily bounds 2, because these are just these are 4 meetings that we're adding. So it's sort of a constant time of meetings or a constant amount of meetings. So with that said, I hope that this video is helpful and I will see you in the next one.